Hello. Hello, hello everyone. Welcome to day two of RTMML 2022.
স্যার একবার চেক করে দেখলাম, ঠিক আছে। এখন স্যার অন্য কেউ যদি ঢুকে একবার চেক করবে, একটু চেক করে নিতেও পারে কথাবার্তা বললে। আমি নিজে একটু কথা বলে দেখে নিচ্ছি। আপনি এই লিঙ্কটার প্রথম দিকটা একটু গিয়ে একটু পেছন দিকে স্ক্রল করলে দেখতে পাবেন ওখানে অলরেডি হচ্ছে, মানে আমি একটা ওই ওয়েলকাম টু ডে 2 বলে একটা বলছিলাম, সাউন্ড আসছে দেখছি। এটা চেক করে দেখেছি, এবারে দেখা যাচ্ছে কি অবস্থা। হ্যাঁ হ্যাঁ, আমি আর কারো শান্তন স্যারের সঙ্গে আমি কথা বলে নিচ্ছি যে ওই স্ট্রিমিংটা যেন উনি ওখান থেকে ওপেন না করেন আর কি, সেটা বলে দিচ্ছি। হ্যাঁ হ্যাঁ। হ্যালো, শান্তন স্যার আছেন? আচ্ছা, চলো করে স্যার। আচ্ছা আচ্ছা, ওনার ওনার পাশে কে থাকে বলুন তো? বর্মন স্যার থাকে? আচ্ছা ঠিক আছে। বলছি আজকের স্পিকার কে? সুপর্ণা সেন। আচ্ছা, কিন্তু এখন ঢোকেননি।
Good afternoon to one and all. On behalf of organizing committee, I welcome all dignitaries, our eminent speakers and participants on the second day of FDP on research trends and methodologies in machine learning, that is RTMML 2022, organized by Department of CSE, CSE, AIML, CSE Data Security and CSE Cybersecurity in association with IQAC of HID. Now we have Dr. Sriparna Saha with us today. Dr. Sriparna Saha is currently an associate professor and head of Department of Computer Science Engineering, Indian Institute of Technology, Patna, India. She has authored or co-authored more than 300 research papers and published her research in top tier venues like ACL, AAAI, SIGIR, NAACL, COLING, ECIR, and IEEE ASEAN Transactions, Scientific Reports, Elsevier, and Springer journals. Her current research interests include natural language processing, machine learning, information extraction, text mining, and multi-objective optimization. Her H index is 31 and the total citation count her papers is 5,753 according to Google Scholar. She is the associate editor of IEEE ASEAN Transactions on Computational Biology and Bioinformatics, ASEAN Transaction on Asian Low Resource Language Information Processing, IEEE Transactions on Computational Social Systems, Expert Systems with Applications, TLOS 1, Pattern Recognition Letters, IEEE Internet Computing, Neurocomputing, Engineering Applications of Artificial Intelligence journals. She is regularly serving as senior PC member of AAAI, ECML, PKDD, etc. Now I am inviting Madam to deliver her talk on the topic of multimodal summarization.
Hello, sir. Am I audible? Hello, sir.
Madam Dr. Saha,
Am I audible? I am not audible. Am I audible?
Yes, ma'am, you are audible.
Okay, okay. Dr. Abhijit, are you? Am I audible?
Ma'am, you are audible, completely audible.
Okay, okay. And can you please see my screen?
Yes, ma'am, your screen is visible.
Okay, okay. Thank you. Thank you. So yes, so
Okay.
yeah, first of all, thank you very much the organizers for inviting me in this particular workshop.
yes,
And yes, hello. Okay. So yeah, if there will be any problem with the
okay.
with my audio or my presentation, please let me know. Okay. I hope it is all right. My audio is clear and my slides are also visible.
Yes, ma'am. It is clear and fully visible.
Okay, okay. Thank you. Thank you for the confirmation. Yes, so today I will talk on multimodal summarization systems. So already as I introduced, so I am currently associate professor and the head of the Department of Computer Science and Engineering, Indian Institute of Technology, Patna. And this is my web page. And my email address is sriparna@iitp.ac.in or sriparna.shaha@gmail.com. So yes, so I today I will basically discuss about the summarization systems and basically a new kind of summarization system which is called the multimodal summarization system. So first of all, what is the summarization? Basically, summarization is a kind of a sub task of natural language processing. So in natural language processing, we have to deal with the natural language text. So you know that natural language processing is a kind of a subfield under artificial intelligence. So in natural language processing, we need to somehow deal with the text written in natural languages. You know, natural language texts are very much abundant in our day-to-day life. Like whenever we are writing something, we are writing in our natural languages. We are writing on the social media, we are posting in the blogs, or we are reading the newspapers. These newspapers are also written in many natural languages. And especially if you consider the Indian setting, in India there are many official languages, and we all are basically multilingual. So we often switch from one language to another. So we can read and write many languages. So basically that's why natural language processing is very much relevant for in Indian context, because it deals with the information extraction from the natural language text. So the in the text is written in natural language, and we have to basically extract information from the natural language text. So basically here in summarization, the task is to automatically create a compressed version of the text document. So a text document could be a set of tweets, a set of web pages, either a single document or a multi-document. So so we are basically considering here the text document, and this text document can be a set of tweets. It could be like a set of web pages, or a single document, or the multi-document, and we have to generate a summary. So this summary is nothing but the compressed version of the text document. So summary should be concise, relevant, non-redundant, and representative of the main idea of the text. So if suppose this is our original document set, now we have to generate a summary, and this summary is basically the compressed version of the text document. So a text that is produced from one or more text that conveys important information in the original text, and that is no longer than the half of the original text. So there will be some limit, there will be some length restriction on the summary. So summary is having a limited length, and also you know that the summary should contain the relevant information which is present in the original set of documents. So original set of documents contain some information, and basically in the summary also we are keeping the that information intact, and the summary length is also basically limited. So there are several goals of summarization. You know, summarization helps us in compressing information. Now you do not have to go through the entire multiple documents. Maybe, for example, one application of summarization could be, suppose a event has happened, and there are multiple newspapers which are reporting about the particular event. So now you know that maybe you do not have time to go through all the news reports. So we can generate a summary, and this summary can give us the compressed version of all these news reports. So this summary will contain the relevant information which is present in all the news reports. So this summary will cover the theme of the central idea. So it will help us in identifying the main idea of the text. It will also help us in active reading. So basically now we will be able to, we will be able to read multiple documents. We will be able to basically understand the contents of multiple documents in a very limited amount of time by reading the summary only. We do not have to go through the original documents. So it is very easy to implement, because if you can easily get the summary, then according to the summary, you can take many decisions. So otherwise, what will happen? You need to read the entire document, then only you can come to a decision. But as you know that it is very easy to implement, because you know it's basically you know it's a summary, so it's basically limited in size. So we need to spend less amount of time to read the summary. It also saves time, by as we now do not have to read the entire document, and sometimes it can also help in decision making. So decision making means, for example, you know, during a disaster situations. So people are connected in during disaster situations. People stay connected with each other in social media platforms. So they used to write about their, you know, physical. They used to write about their they basically they used to write about their status in the social media platforms. So what we can do, we can basically collect these tweets or the social media feeds from the social media data, and then maybe we can generate a summary out of those social media feeds. Dr. Abhijit, can you please allow my student? So I think he is waiting. So his name is Santosh Mishra.
Okay, ma'am.
Yeah, he is not getting access. Yeah. Yeah, so these are the several advantages or goals of a summarization system. So as I mentioned that it has many applications, compressing the information, saving time, helping us in active reading, then decision making, because you know that by reading the summary you can easily understand the entire document, so that will help us in taking quick decisions. For example, in the disaster situations, as I mentioned, if we can collect the tweets, during in the tweets people may express their feelings or their current condition, and they can basically write about their present condition in the tweets. So maybe we can collect those tweets and then we can extract relevant information from the tweets, and then that information can be given to the that information can be given to the rescue team, and the rescue team can easily plan for the rescue operation by seeing this microblock summary. So in general, summarization is of two types, extractive and the abstractive. So extractive, from the name itself, you can easily understand it is a extraction process. So it is quite easy compared to the abstractive summary. So in extractive, we are, if suppose your original document is having 1000 sentences, now you have to carefully select a subset of sentences to be in the summary. So it's basically a subset selection problem, and often it is formulated as an optimization problem. So basically we have to select a subset of sentences to be in the summary, and each sentence will be assigned a score, and then we have to rank the sentences based on their scores, and we have to select the important sentences in the summary. So sentences can be ranked by based on many features like sentence position, similarity with the title, etc. And there is another paradigm which is called the abstractive summarization. In case of abstractive summarization, you know that we have the original text, and now we are generating some new sentences in the summary. So suppose in the original text we have 4 sentences, and we are generating some new sentences in the summary. So it is a kind of a natural language generation. We are rewriting the original sentences and we are creating some new set of sentences. So basically it requires the reconstruction of the sentences. So it's more difficult because here we need to generate some new sentences, and these new sentences should follow the English grammar, the grammar of the particular language, and also those should be readable, and those should also contain relevant information. So natural language generation is a very difficult task because it is a human-like intelligence, and developing models for natural language generation is also more complex compared to the extractive summarization. So here is one example. You can see that if this is the original document, then if we are simply selecting the colored lines, then that is an example of the extractive summary. So we are simply selecting the colored lines, and then we are generating the summary. And in this case, you can see that we are rewriting the sentences. So these are the original sentences, and now we are rewriting the sentences. We are generating new sentences. So this is the abstractive summary. So now there are many examples of many types of summarization. One type is basically called the query focused summarization. So in the query focused summarization, you can, from the name itself, you can understand that suppose there is a query, suppose we are querying with the word Taj Mahal, and we will be able to retrieve many web snippets on many web pages which will talk about Taj Mahal. And now if we can generate summary of all those documents, then this is called the query focused summarization. If we are summarizing a single document, then this is called the single document summarization. And if suppose on a particular theme, we have multiple documents. So as I mentioned that suppose there is an event, there is a sports event, and multiple newspapers are reporting that particular sports event. So we can have multiple news reports. And then we have to generate a summary considering all these reports. So this is called the multi-document summarization. Then there is a third concept called the figurative summarization. So in the biomedical articles, you can see there are many figures, and the figure captions are not very detailed. So figure caption is very brief, and you will not be able to understand the meaning of the figure by reading the figure caption. So the figure is basically described in text, and by going through the text, we can easily generate the summary for the figure. So this is called the figurative summarization, where basically what we are doing, we are simply giving the input, the figure and the input text, and then we are generating the summary of the particular figure. I told them. I told them. Yeah. So, sir, please let my student be in this call, huh?
Ma'am, he sent his email ID.
What? What you mean?
Email ID of Mr. Santosh Mishra.
Okay, okay. 1 minute. Yeah. I said.
Thank you, ma'am.
Yeah. Is my screen visible? Hello?
Yes, ma'am. Perfectly.
Yeah. Yes. Okay, and yeah, so I was discussing about the figurative summarization. So, in figurative summarization is very common in the biomedical articles. As I mentioned, that in biomedical articles you can see many figures, and the figure captions are not very detailed. So, figure captions, by seeing the figure caption, you will not be able to understand the figure clearly. So, you need to generate a summary for a particular figure if you need to understand the figure. So, here the input is the text document and the particular figure, and we are generating the summary of the particular figure. So then we can also have the web-based summarization. So in the web-based summarization, we can summarize the web pages. Like suppose you are searching in the Google with some word, with some particular query. So like maybe you are searching with the query, Sachin Tendulkar, and you will get many web snippets. And now if you can generate a summary of all those web snippets, then that is called the web-based summarization. Then we can have the email based summarization. So if suppose we are summarizing the emails, so a customer care, in the customer care section of each company receives multiple emails, and they really do not have time to go through all the emails. See if we can generate a summarization system which can produce a summary of all the emails. Then we can have the personalized summarization. So here we are basically summarizing the information specific to a user's need. For example, maybe so when we are summarizing the web snippets corresponding to the Sachin Tendulkar, you will get many web pages. So some web pages will talk about Sachin Tendulkar as a sportsman. Some will talk about Sachin's personal life. So some will talk about the Sachin's current Sachin's current profession, etc. So basically, that now maybe the user is more interested in the personal life. So accordingly, we can put focus on those documents or those sentences which are related to the personal interest or user's personal interest. So here, from user to user, summary may vary. So keeping the users, the context or the aspects of the personalization in mind, we can generate summaries. Then we can also have the sentiment based summarization. So where that suppose there is a product, and a particular user has reported has written reviews of the particular product, and now we want to generate summary of those, basically summary of those products, summary of those reviews. So then this is called basically the sentiment based summarization, because when a user is writing a review, he or she is also expressing the opinions, or maybe sometimes there will be positive sentiment, sometimes negative sentiment, and a product can have multiple aspects. So for example, a mobile phone has many aspects, like camera quality, the display, or the battery life, etc. So when we are writing our opinions of the reviews, we are also mentioning the aspects. So multiple aspects and their corresponding reviews the users used to put. So maybe we can develop some aspect based summarization. So for a particular aspect, we can collect all the reviews, and then we can generate a summary for that. Then, as I mentioned earlier, one important application of summarization is in microblog domain. So we can collect multiple tweets, and then we can generate summary of those tweets. So this is called the microblog summarization, which is very, which is very much useful during the disaster situations, because during the disaster situations, people's physical connectivity is lost, and people stay connected with each other in the social media platforms. So they used to basically post their updates in the social media platforms. So we can what we can do, we can basically collect tweets or the social media feeds, and then we can generate a summary of those feeds. So this is called the microblog summarization. So now all these summarization systems can be developed in two different ways: supervised or the unsupervised. So supervised means that here we have the label data. So basically that in the supervised setting we have some label data. So means we already know some input document and the corresponding summary, and by using this parallel corpus we can train some models. And then and in the unsupervised way, this training data will not be available. And what we can do is that we can simply cluster the sentences in the semantic space. So suppose we have multiple sentences, so we can cluster the sentences we can basically cluster the sentences in the semantic space, and then from each cluster we can select one important sentence to generate the summary. So that is the basically the unsupervised way of handling the summarization problem. So now that there are in the summarization process, when we are talking about the extractive summarization. So in the extractive summarization, we have to extract some important sentences from the original set of sentences. So for example, for the in the original document, maybe we have 1,000 sentences, and now we need to maybe we have to select maybe a subset of sentences from that, basically from for generating the summary. So there are several quality measures for summarization. One is the basically the diversity or the anti-redundancy. Here our aim is to improve the diversity of the summary. So basically that summary should have diversified sentences. Then the second is the position of the sentence in the document. So position of the sentence in document also plays a very major role. The initial sentences of a particular document contain more information than the later sentences, because you can easily see when suppose you are reading a news report. News reporters used to used to briefly discuss about the event in the initial few lines. So the position of the sentence in document is also a one objective function. The length of the sentence is also one objective function, because longer sentences contain more information than the shorter sentences. So the length of the sentence is also an important factor. Then coverage. So we need to cover the entire theme of the document. So we have to select sentences in such a way the entire theme can be covered. Then cohesion. The sentences should be coherent to each other. And another aspect is the readability. So the readability aspect of the particular summary should be high. So summary should contain multiple sentences, and the readability aspect should be high. Then sentence similarity with the title should also be high. So the sentence, if the sentence is similar to the title, because some title can also be considered as a kind of a summary only. So when we are providing a title is also a kind of very much abstract summary. So if a particular sentence is very much similar to the title, then that sentence should be given more importance. So now, what is the multimodality? So, now I will basically discuss, till now I was discussing about the text summarization techniques. So I will now mostly focus on the multimodal summarization, because multimodal summarization is a new concept and just introduced in recent years. So people who are mainly working on the text summarization, they were considering the documents written in natural language text, and they were generating the summaries. But nowadays multimodal information is very much abundant. So for example, when we are writing in social media, we are not only writing in text, but we are also uploading images and the videos. And newspapers also, you can see in news reports also, reporter is not only writing the textual description but also putting some images images to, so that the reader can easily understand, or he can understand better the concept. So multimodal information is very much abundant, and you know that our experience of the world is basically multimodal, because in our real life also, whenever we have to take decision about a particular object, we used to see the object, we used to hear the sounds, feel the texture, smell the odors, and taste the flavors. So we used to collect information from multiple sensors, and then we come up to a decision. So basically, you know, this multimodality is nowadays very much common, and multimodal learning consolidates heterogeneous data from various sensors and data inputs into a single model. So, you know, it is basically collecting information from multiple sensors, and then it is basically consolidating those information, and then it is making a single model considering all this information. So the approach of training models on only single source of information, such as either text, audio, or video, is commonplace. But there is also a way to build models that incorporate multiple data types, say text and images at the same time, called multimodal information processing. So basically, if we are collecting information from multiple modalities, text is one modality, image is another modality, video is could be another modality. So if we are collecting information from multiple modalities, then you know, then this is called the multimodal information processing. So basically, here we have to first extract information from multiple modalities, then we need to fuse them together, and finally we have to process them, process this fused information to take a decision. So why multimodal summarization? So first point is the abundance of information in the multimodal form. So because when we are collecting data from the Twitter, we are not only collect the textual data, but also the images and the videos. Because in social media platforms, we have this data, we have the Twitter, we have the multimodal data. Then you know that multimodal summaries, and also the second thing is the user satisfaction. So it has been found that if we provide some image in the summary, that basically helps us in improving the user satisfaction, because there are some concepts which are better described in text, and there are some concepts which can be better described in image. So image and text are basically somehow, you know, complementary to each other. So we can like for example love, affection, etc. So these concepts can be better described using text. It's very difficult to, you know, it's very difficult to basically show some images to describe these concepts. And then there are some concepts like, you know, there are some concepts like piano, how a piano looks like. So you know, it's very difficult to describe these concepts, you know, using text. So basically image and text are somehow, you know, complementary to each other, and some concepts are better described using images, and some concepts can be better described using text. So that's why we need to have multiple modalities to while we are outputting the summary. And in the input also we should consider multiple modalities, because data is nowadays available in multimodal format. You can see the newspapers, you can see the social media or the blog post. Everywhere users are not only uploading the text but also uploading images and the videos. So from the images and the videos we can collect some relevant information which can further help us in improving the summary. So in recent years, you know, in IIT Patna, we have a research team, AINLP Artificial Intelligence, Natural Language Processing, Machine Learning Research Group, and we are basically focusing on doing research in the cutting edge problems of natural language processing. And as I mentioned, summarization is basically a sub this discipline under natural language processing, and we just started working on this multimodal summarization. Because there was not much work on multimodal summarization, and basically we started working in this particular field, and we also created a new data set for this multimodal summarization, and we developed 2-3 techniques for multimodal summarization. So these are some papers related to this particular domain or research domain. So now let me first introduce the task. So this multimodal summarization can also be termed as a TIVS task, or text, image, video summarization task. So here in the input side, we are considering the multiple text documents we are considering multiple images and the multiple videos. So in the input, we have multiple input documents, then we have multiple images, and we have multiple videos, and then we are processing something, we are applying some summarization. This summarization could be extractive summarization or it could be abstractive summarization, and finally we are generating summary. So the summary is again having can have three components. There could be a text summary, some images can be added in the image summary, and there could be one video in the video summary. So basically, this is the basically the multimodal summarization task. So, basically, yeah. So now let me discuss about the data set. So, in this particular paper, Zhu et al., they first started working in the multimodal summarization. So, as I mentioned, this multimodal summarization is not a very old term or old research area. It got only started in 2017 by Zhu et al. So, Zhu et al. First developed a method for this for developing the multimodal summary. So in their paper, they proposed a data set. In the data set, there are 25 topics. Each topic is having 20 text documents and 3 to 9 images, 3 to 8 videos, and 3 text references per topic. So now you know that this is the data set, and now, but in this data set, they have considered multimodalities in the input side, but in the output, there is only text summary. So we basically extended this data set to have multimodality in the output summary as well. So in this data set, in the output there was only text summary. Now we have basically used some annotators to select some images for the image summary and to select also a single video for the video summary. So 3 annotators were employed to score each image and video on a scale of 1 to 5 on the basis of a similarity to generate a multimodal summary. So average annotation scores were calculated for each image and video, and multiple images and videos are selected based on average annotation scores to evaluate the model. So basically this way we have prepared the data set. So now we are generating multiple modalities in the output as well. So in the input we have only text, image and videos, and originally there was text summary in this particular Zhu et al.'s data set, but now using this manual annotation we are also adding some text, image summary and the video summary in the output. So now let me discuss about the first work, which is using an integer linear programming framework for solving this multimodal summarization problem. And this got accepted in European Conference on Information Retrieval 2020. So it is a category A conference. So this is the overall framework. So we have the multiple documents, we have the multiple images, and we have the multiple videos in the input. Now from the videos, we are extracting the keyframes. Keyframes are added to the image set, and we are also generating the speech transcripts. And now speech transcripts are basically giving us the sentences, and those sentences are added to the text set. So finally, in the integer linear programming, we are giving the one text set and one image set as the input, and this is the joint integer linear programming framework. I will now discuss about this in detail. And after application of this integer linear programming framework, we are selecting some sentences in the text summary, and we are selecting some images in the image summary. Then we are applying some post-processing tool, post-processing steps, and then we are adding some more images in the image summary, and we are also selecting a single video in the video summary. So this is our final summary where we have a text summary, there are multiple images as the image summary, and there is one single video as the video summary. So now this is the basic skeleton of the integer linear programming, because we have to map the summarization problem to the integer linear programming framework. So in the integer linear programming framework, there must be some decision variables. So basically we need to find out the values of these decision variables. And then there must be one objective function which has to be optimized by the process of integer linear programming. And there must be many constants. So these constants are used, are restrictions used to formulate a problem and incorporate real life knowledge of the intuitions. So we have used the Gurobi optimizer as the linear integer programming optimization. So this is our joint integer linear programming framework. So basically our decision variables are 3 matrices. So we have one matrix for the text, one matrix for the image, and the third is the intermodal correspondence. So basically we have a square matrix, So the square matrix diagonal elements represent the cluster centers, and the non-diagonal represent whether those points will belong to a cluster or not. So diagonals represent whether a particular point is center or not. So you know that here, if the diagonal is 1, that means it's basically a center. So it's of size n into n. It is a binary square matrix. And then for the image, we have this P into P binary square matrix. So we are basically generating clustering of the sentences. For this matrix is required. This is a kind of adjacency matrix. So if the diagonals are 1, that means that particular sentence is selected as the cluster center. And the other elements, suppose ij equal to 1 means ith point belongs to the jth cluster. And these are all binary matrices, so either it can take value 0 or 1. Now we can also have the image matrix. So in the image matrix of size P into P, so diagonals basically represent the image cluster centers. So diagonals basically represent the image cluster centers, and again basically by using this matrix we are generating the image clusters. Then there is a n into p binary matrix which basically checks the similarity between a sentence and an image. So you know that this is the thing, AIML, the diagonals represent whether a particular sentence or image is selected as an exemplar or not. AIMIJ whether xi votes for xj as its exemplar, and AIMIJC means if there is a threshold level of correlation between si and ij. So C is the cross model. So now this is the objective function. You can see we are computing the saliency of the text cluster, saliency of the image cluster, and the cross model correspondence. So saliency score for a given matrix. So underscore core is the multimodal correspondence. So saliency is nothing but the similarity between the cluster center and all the other points in the cluster. So you can see saliency is computed like this. It is basically we are checking whether the cluster at this particular point is the cluster center or not. And then the importance is basically the cosine similarity between the point and the all other points in the cluster. So it is a cosine similarity between a particular cluster center and all the other points in the particular cluster. So this way we are computing the saliency of the text. Similarly, we are computing the saliency of the image. So we are also finding out the image cluster centers, and then we are computing the all the other points which belong to the image clusters, and then we are computing the saliency. Now we are also computing EM cross model correspondence. So the cross model correspondence is basically this one. So you can see that it is the similarity. It is the basically similarity between the text cluster center and the image cluster center, because we do not want to keep the disjoint image cluster and the image summary and the text summary. Somehow text summary and the image summary should be related, means they should be supplementary to each other. That's why you're also determining the similarity between the sentence clusters and the image cluster centers. So these are the three components, but as integer linear programming can only optimize a single objective function, so we are basically combining them in a weighted fashion. So lambda, we are basically making a weighted combination of these three functions. And now there are some constants. All matrices are binary. So either this AIMIJ could be 0 or 1. So AIMIJ is 0 means ith point does not belong to the jth cluster. AIMIJ equal to 1 means ith point belongs to the jth cluster. And all the diagonals equal to 1 means basically all the diagonals equal to 1 means that is a cluster center. That particular point is a cluster center. And there is another constant, there must be exactly k txt number of text clusters. So we are basically fixing the number of clusters. So here we have not varied the number of clusters. We have fixed the number of clusters, text clusters, and the number of image clusters. And then an entity can either be an exemplar or be a part of a single cluster. And an entity to be endorsed by any other element, it must first be an exemplar in its vector space. So all these constants basically are satisfied, and we have to optimize the objective function. So now for the post-processing, we given the text summary and the top aim images from the image set, we have to apply some post-processing. So by post-processing, we need to add some images in the image summary, and we have to add a video in the video summary. So basically we have to apply some post processing. So you have to select the non keyframe images. So other than these images, select those images we have cosine similarity between alpha beta. These images that have similar annotation scores would help users gain more insight. So you can see that we are what we are doing. We are basically first we are extracting the text summary and the image summary, and now we are also generating a video. We are selecting a video as the video summary. So for selecting a video and as the video summary, we are comparing two scores, visual score and the verbal score. So each video is having some keyframes, and we are basically identifying all the keyframes, and then we are finding out the cosine similarity between the images in the image summary and the image and the keyframes, and that gives us the visual score. And now there is also a verbal score. So we are selecting all the text sentences in the text summary, and then the sentences in the speech transcripts, and we are finding out the cosine similarity between the text summary and the speech transcripts, and that gives us the verbal score. So basically each video is assigned a score, which is a summation of visual score plus verbal score. We rank all the videos based on the summation of the scores, and we select the video having the highest score. So now, these are the results. You can see that like we are comparing with respect to different baselines. The last one is our proposed system, joint integer linear programming multimodal summarization, and we are computing the different ruse score values. So ruse is basically a kind of, it's a evaluation metric which is used to check the similarity between the generated summary and the actual summary. So ruse is here we are using the ruse scores. So you can see that ruse is a very popularly used metric for summarization. So actually, you know that on this particular data set, we already know the actual summary, and our system is producing a summary. Now we are checking how many sentences are common in between, and that basically gives us the ruse score. So it is a basically string overlap matching. So it is matching the highest string overlap. So we can see that we are getting the highest values with respect to ruse 2 and the ruse L. So we are also computing the image quality of the image summary. So average precision, average recall, variance precision, variance recall, these are calculated. We are varying the inter-annotated agreement, and then we are computing the precision and the recall values of the images. We have also computed the video accuracy. So you can see that we are getting around 44% accuracy, because in the video summary there is only one video. So whether we are getting that particular video in the video summary or not, so it's a binary decision. So that's why we are now calculating the accuracy, as there are it is a binary classification. So we are getting 44% accuracy. Yes, so if you have any question from this method, you please ask me. If any question from this particular work, you can ask or you can chat also.
So, ma'am, what I will do, if there is any question, I'll send them on this chat box.
Sure, sure. Okay, then let me continue.
Yes, ma'am.
Yeah. So yes, so this is the, I just have shown you how we can, modify a existing framework. Like integer linear programming is a very popularly used optimization framework. So basically, how can we formulate the summarization problem, especially the multimodal summarization problem, in terms of integer linear programming, and then solve this multimodal summarization problem by integer linear programming. So this is the first thing. Now I will show you how can we also apply some multi-objective optimization concept for solving the multimodal summarization. So here you have seen that integer linear programming cannot optimize multiple objective functions. So what we have done is that we have combined all the objective functions saliency of text clusters, saliency of the image clusters, and the cross-modal correspondence into a single objective function. And then by using this, basically, we are by using this objective, we are basically optimize this objective function by using the integer linear programming. So that this is the second technique, multi-object optimization using differential evolution. So here we will show you how multi-object optimization can be used to solve the problem of multimodal summarization. So basically, let me start with the discussion that what do we mean by optimization. So optimization we all are familiar with. In the optimization, we have to optimize some objective functions. So in our day-to-day life, we often encounter different optimization problems. So there are two types of optimization frameworks: single objective and the multi-objective. In the single objective type, we are optimizing a single objective function. For example, suppose you want to purchase a car. So then the cost is one objective function. So you want to basically optimize the cost. So basically we want to minimize the cost. So this is an example of single objective optimization. But if you are optimizing multiple objectives, like suppose cost and compute, we want to optimize both. And cost and compute are conflicting to each other. We want to minimize cost, but we want to maximize compute, and that is not possible simultaneously. So if you want to minimize cost, then compute will also be compromised. And if you want to maximize compute, you have to pay more. So cost and compute are basically conflicting objective functions, and though these two cannot be simultaneously optimized. So these type of problem statements are called multi-objective optimization. So one example could be, suppose you want to go from Haldia to Kolkata. So there are many options. Or for example, if you want to go from Kolkata to Delhi, so you have many options. You can go by train, you can go by road, or you can go by flight. So their time and cost are basically two factors or two objective functions. If you want to minimize time, then cost will go high, and if you want to minimize cost, time will be high. So time and cost are basically conflicting objective functions. So these type of problems are basically called multi-objective optimization problem, where you have to simultaneously optimize multiple conflicting objective functions. So here, for example, you can see that suppose in case of multi-objective optimization, it is very difficult to get a single solution. So rather, we can get a set of solutions on the which is called the parallel curve or parallel surface. So we are getting multiple solutions on the parallel surface, and we can compare. Like if you compare these solutions are called non-dominated to each other. So one solution is better with respect to one objective function, but the other is better with respect to the other objective function. So we cannot directly compare a solution with the other. For example, if you compare solution 1 and solution 2, solution 1 is better with respect to safety, but solution 2 is better with respect to cost. So we can't say that solution 1 is better than solution 2, or solution 2 is on the need, can select a single solution from the parallel surface. So this is the formal definition of multi-objective optimization. We have to find some decision variables which will satisfy some constants. So these constants could be some inequality constants or equality constants, and there will be multiple conflicting objective functions. So for example, constants could be that the car should have a seat for 6 adults. Or maybe the car should have mileage of 20 kilometers per liter. So like this way we can basically incorporate many constants in the optimization framework, and then we can also have multiple objective functions. So our task is to simultaneously optimize multiple objective functions while satisfying the constants. So finally the task of the multi-objective optimization is to get a set of solutions on the parallel optimal curve. So finally, generate a parrot optimal card, and then from the parrot optimal card, we can get a single solution. So this is one example of dominance and the non-dominance. You can see there are two objective functions, f1 and f2. We are maximizing both the objective functions. Now these are the four solutions on the parrot optimal curve surface. Now if you compare solution 1 and solution 2, solution 1 is better with respect to f2, but solution 2 is better with respect to f1. Hello? Okay. Yes, so basically you can see that solution 1 is better with respect to f2, but solution 2 is better with respect to f1. So we can't say the solution 1 is better than solution 2 or solution 2 is better than solution 1. So these two solutions are called non-dominated solutions. Now if you compare solution 5 and solution 2, for both the objective functions, you can see that solution 5 is having lower objective functional values compared to solution 2. So solution f1 and f2 values of solution 5 are lower than those of solution 2. So solution 5 is basically dominated by solution 2. So now this is the overall architecture. You can see that like we have, in the input side we have the text documents, images, and the videos. And again, we are basically extracting from the videos. We are extracting the key frames and we are extracting the key frames and also the speech transcripts. So before processing the videos, we are doing some pre-processing. We are extracting all the key frames. We are adding those key frames to the image set, and we are applying the speech recognition, automatic speech recognition modules. We are converting the speech to text, and then those sentences are added to the text set. So now we have the text set and the image set in the input. We are projecting them in the same space. So here we are applying VGG19. Here we are applying some feature vector generation. We are projecting them in the shared space. And then we are generating some text vectors and image vectors. And now you can see that this is the, this is our optimization framework. So, we are having initialization, then there is a population initialization. So population is consisting of multiple solutions. So each solution is basically having multiple cluster centers. So I will now discuss. So the population is consisting of multiple solutions, and then we are generating we are applying some operators to generate the new population. Now the new and the old populations are merged together. Then we are selecting the base P solutions for the next generation. We are selecting, basically after merging, we are selecting P base solutions for the next generation. So here selection operation is done by non-dominated sorting and the crowding distance. Then we are checking for the stopping criteria. If stopping criteria is met, then we are, one second. Hello, am I audible?
Yes, ma'am.
Yeah. Yes, so basically, we are generating some image vectors. So you can see that by using the VGG19, it's a deep learning based model. We are converting the images into some vector representations, and also by using this method, which is available by using this Fisher vector generation method, we are generating some text vectors, and then by using this shared embedding using P10 models. So this model is available in this IEEE CVPR paper. In this 2016 paper, they have basically proposed a model. How can we project the text vectors and the image vectors in the common space? So we are generating some text vectors and the image vectors, and now we are applying the multi-object optimization. So this part is basically the multi-object optimization approach. So it's very similar to the differential evolution. Differential evolution is a meta-heuristic optimization technique. So differential evolution maintains a population. So population is consisting of multiple solutions, and then we are applying some genetic operators for generating new solutions. We are merging the new population with the old population, and then we are applying the selection operation to select some best P solutions for the next generation. So yeah, so this way basically, and finally we are generating a parallel surface. On the parallel surface, at the end, there is a loop. So there are these operators are there is a loop. So that this generating new solutions, merging of the new population with the old population, then selection of the best solutions. This will continue for a number of generations. And finally, when we meet the stopping criteria, we obtain the parallel solution set. Now this paradigmal set is having multiple solutions. Each solution is having a text set, text summary, and also image summary. So now we are generating the final summary. In the final summary, we have a text summary, image summary, and the video summary. So you can see that this is our proposed approach. So basically here population is consisting of multiple solutions, and we are considering a solution. A solution is basically consisting of some text cluster centers and the image cluster centers. So you can see that a solution is having some text cluster centers and image cluster centers. So we have fixed the maximum number of text clusters to k underscore txt and maximum number of image clusters to k underscore image. So we are selecting randomly these cluster centers from the data set, and now we have applied the k-meter algorithm to obtain the clustering. So these are the cluster centers, and then we have assigned the sentences to these clusters based on some cosine similarity. And now we are applying some crossover operations. So you know that suppose these are the solutions, it is single point crossover. We are applying the crossover operations and we are generating some offsprints. Then we are also generating some, we are applying some mutations. So there are three types of mutation operations: polynomial, insertion, and deletion. So you know, polynomial means you are changing some components of the vector. So suppose we have the text vector and the image vector. So we are simply, we have the the image cluster centers and the text cluster centers. We are simply changing some components of those vectors. That is the task of the polynomial mutation. By insertion mutation, we are inserting some new cluster centers, and by deletion mutation, we are deleting some new cluster centers. So then this is the selection operation. So in selection operation, we are merging P and P dash, and now this is the 2P number of solutions. Now from this 2P number of solutions, we are selecting best P number of solutions till the termination criteria is satisfied. So you know that for selecting the best P number of solutions, we are applying some selection operation. So this selection operation, you know, that has two components: non-dimensional sorting and the crowding distance. So first, we are distributing this 2P number of solutions into different rank set. So you know, these 2P number of solutions are distributed in rank set. So rank 1 solutions are the best solutions, which are not dominated by any other solutions. Rank 2 solutions are those solutions which are dominated by rank 1 solutions, but they are non-dominated to each other. Rank 3 solutions are dominated by rank 2 solutions, but in the front there are multiple solutions which are non-dominated to each other. So this way we are applying the non-dominated sorting. And then we also apply the crowding distance. So crowding distance means we need to check the distance from the neighborhood. If suppose the solution is in a less crowded neighborhood, then the solution is more important. So this way basically we are applying the crowding distance and the non-dominated sorting, and you know that we are obtaining the path-optimal solution set. So yeah, so this is the so this is the selection operation. So yeah, so here now about the objective functions. So there are two types of objective functions. One is summarization based, another is the clustering based. In the clustering based, we are mainly focusing on the quality of the clusters. So as you have seen in the solution, we have the set of clusters, set of text centers and the set of image centers. So now what we are doing, we are applying the clustering on the text side and also clustering on the image side. So yeah. So basically, PBM index is a cluster validity index which is used to check the quality of the text clustering, and we also have the PBM index which is checking the quality of the image clustering. So we have the PBM on the index calculated on the image clusters, PBM index on the image on the text clusters, and the cross correlation. So cross correlation stands for cross-modal correspondence, and PBM is the Pakira Bandhavadhyay Maulik index. It is a cluster validity index. Now for the summarization type, we have the saliency of text by redundancy of text. So saliency calculates the similarity, or basically saliency basically calculates the similarity of a particular cluster in terms of the cosine similarity, and redundancy calculates the basically similarity between two cluster centers. So our motto is to minimize the saliency and to maximize the redundancy. So basically these are multi-objective based framework. So you can simultaneously optimize multiple objective functions. That's why in both the framework we have three different objective functions. One objective function basically checks the quality of the image clusters. Second checks the quality of the text clusters, and third checks the cross-modal correspondence. So saliency is nothing but the similarity between the cluster centers and individual points, and the redundancy basically checks the similarity between two cluster centers. So basically you can see that it checks the cosine similarity between two cluster centers. We need to basically maximize this. We have to minimize the saliency. And the cross-modal correspondence is basically similarity between the image cluster center and the text cluster center. So now post-processing, basically we are doing some post-processing as well. So initially we have some text clusters and the image text clusters and image clusters. By applying the post-processing, which I already discussed before, we need to add some video as the video summary. So for that we are assigning some ranks to the videos. So each video is given a average rank of visual score and the verbal score. So visual score is calculated with respect to the keyframes present in the video. So the video is having multiple keyframes, and we are calculating the similarity between the keyframes and the images present in the image summary. And we are also calculating the text, the verbal score, which is calculated based by considering the speech transcript of the video and the text summary. So each video is assigned a score, which is a summation of the visual score plus the verbal score, and the video with the highest score is basically selected for generating for to be in the video summary. So now we are comparing our approach with several approaches. This text rank. These are some existing text summarization techniques. Because in the image summarization there was no existing extractive summarization technique. So we basically compare with all of them, and rules is basically used for the comparison of the text summary, and the image average precision, image average recall are used for comparing the image summary, and the video is compared with respect to the video accuracy. So you can see that we are comparing with respect to this rule scores, and our proposed approach is mostly attaining the better rules 2 and rules well scores compared to the other approaches. So this is one example. You can see that we have applied our approach on 20 articles. These 20 articles are talking about Victory Day celebration of Russia, and this is our generated text summary, and these are the images which are selected in the image summary, and one video is also selected as the video summary. So this is the example summary. So yes, so if you have any question, please ask me.
Ma'am, there are some questions.
Yeah.
As YouTube live streaming is also going on, we are putting the questions here. So the first question, that is, text summarization is very old problem only, but now currently technology, what important things we need to understand?
Okay, yeah. Text summarization is very old problem only, but now current technology, what important things you need to understand? Yes, so many very important. Yeah, thanks for this question. So so basically, as I mentioned, that text summarization is old, but abstractive text summarization is very much emerging, because there are it's very difficult to work on the abstractive setting, where you have to generate some new sentences, and especially in the multimodality. So as I am discussing now, the multimodal summarization, where you are not only considering the text input but also the images and the videos. So here input is in text, image and video, and we are also generating the multimodal output. Like in a summary, we'll be having a text summary, image summary and the video summary. So yes, so basically if you want to work on the text summarization, then do focus on the abstractive summarization, mainly natural language generation modules. You know, with the there are different nowadays many language models like T5, BART, etc. So those can be easily utilized for generating the abstractive summary. And especially, I would also like to mention that in Indian context, there is not much summarization systems available. So most of the abstractive summarization systems are available in English. So you can also think of doing something in the Indian setting. As I mentioned earlier, India is having many official languages, and we often need some summarization systems to summarize information written in different official languages. So maybe you can also think of how can we extend the abstractive summarization frameworks in Indian setting. So Somen, I hope this answers your question.
Thank you, ma'am. There is another question, that is, with a large data set, will this system be performing well?
Yeah, yes, because there is no, we have not assumed anything with regards to the data set size. So, you know, you only need to, like, if you want to handle large data set, then the computational time will be increased, because you have to compute the cosine similarity, because you can see that in our model we are applying clustering of the sentences. So the clustering of the sentences will take more time if you have more number of sentences. So that is the only concern, that if you will have a large data set, the approaches are very generic and those can be applied on small data set, large data set, medium data set, anywhere. But you know, you have to provide, you have to wait for more time, like the computational time will increase in case of large data set, because you have to compute the cosine similarities between the sentences, and that will take some time.
Okay, so my co-host Somen Ghosh is sending question. Another
Yeah.
question, that is, how does multimodality in communication contribute to meaning?
Yeah. So multimodality in communication contribute to meaning. Do you mean how does multimodality in communication contribute to meaning? Yes. So as I mentioned, no, that like multimodality, like image and text are somehow complementary to each other. So you know, we are not able to express something in text which can be easily better described in image, and there are some concepts which cannot be described in image but can be easily described in text. So, you know, image and text are somehow complementary to each other. For example, if you see the concept of love, affection, these are very difficult to be expressed using image, but those can be easily expressed using text. But suppose you have to describe some object, like how a piano looks like. So, you know, it's very difficult to describe in text. So, you know, in communication also, we are often using this image and text together to represent our thoughts or our ideas or our concerns, etc. So for example, suppose if you are writing a complaint, when you are writing a complaint about a particular product, we are not only writing in text, but maybe you are also uploading the images of the particular product. You know, like you suppose you are purchasing a product from the Flipkart, and then there is a defect in the product. So you can see the Flipkart will ask you to upload the image as well. You have to not only write the textual description of the damage, or the why the product is not why there is a damage in the product. Also, you have to they will ask you to upload some images of the product. So this way you can easily understand that sometimes text is not enough. Images do help in understanding better the concept, and maybe image alone is also not sometimes better. Maybe we need to also write something in text. So image, in our case, we assume that text and image are somehow, you know, they are necessary and they are complementary to each other. And that's why you have considered both image and text for generating the summary. So, when does it answer?
Actually, ma'am, Somen is my co-host,
Achha.
and he is putting the questions from YouTube.
Oh, achha,
Actually, these
okay.
questions are actually asked by
Okay.
some other teachers over
I
the YouTube.
understand. I
So
understand.
the next question is, non-dominated sorting genetic algorithm used for every area. But this text summarization, what way of we'll understand?
So non-dominated sorting genetic algorithm we have used as the underlying optimization technique. So basically, as I mentioned, that we are doing, we are formulating the summarization problem as an optimization problem. We are basically first applying the clustering of the sentences. We are first forming the clustering of the sentences, and after that, from each cluster, we are selecting some important sentence to generate the summary. So the cluster center is basically selected to be in the summary. So it's a two-stage approach. First, we are doing the clustering of the sentences, and then in the second stage, from each cluster, the centers are selected, and that will basically form the summary. So here basically we have applied the multi-objective clustering. So because we are simultaneously optimizing multiple objective functions. So for in the image side, we are applying clustering. In the text side, we are applying clustering. And we also want to improve the cross-modal correspondence. Like the image centers should be similar to the text cluster centers. So there are three objective functions. And if you have to optimize multiple objective functions, you need to have a multi-objective optimization framework. So this non-dominated sorting genetic algorithm is basically our multi-objective optimization framework. By using this, we are basically determining the optimal decision variables. In our case, decision variables are the cluster centers, and objective functions are those three. The quality of the text clusters, quality of the image clusters, and the cross-modal correspondence. So non-dominated sorting remains same. It is as it is, which is used in NSGA2. We have not modified the non-dominated sorting procedure. We have used as it is, but now we are considering the solution. Basically, in the definition of our solution is different. In our case, a solution is having two components. There is a text part, there is an image part. So text part contains the text cluster centers, and the image part contains the image cluster centers. Okay, otherwise, so basically now a solution is basically a string. It's a string of some vectors. So, and then we have applied a very similar way, like in NSGA2, this non-dominated sorting was first introduced. So the same approach we have used here for optimization. So NSGA2 or the multi-objective differential evolution are our backbone. So those are used for as the optimization tool. Like in the first work, we have used the integer linear programming framework. And in this particular work, we have used the NSGA2 or the multi-objective differential evolution as the underlying optimization framework. I hope, yeah, it's clear.
Yes, ma'am. We got the answer. So, if anybody from Google Meet, if anybody wants to ask questions to Madam, you could ask.
So, Abhijit, should I continue, or I should ask my student, like as I mentioned, that there will be a demo session as well. So my PhD student Santosh Mishra is also in this call. So he will show you how can we develop a summarization system. So we just want to give you a demo also, because I just discussed about the theory, but maybe if you can understand the practical implementation of these summarization systems, that will be better for you.
Yes, obviously, ma'am, you can start. Means Mr. Santosh Mishra can start right now.
Santosh, are you there?
Yes, ma'am, I'm here.
Yeah, you then continue, okay, and then I am here only.
Okay, ma'am.
Maybe,
Okay, sure,
yeah,
sure.
yeah. Maybe you can start with your approach.
Okay, okay, ma'am. Okay. So, good evening to all of you. So, am I audible? Clearly audible?
Yes, Santosh, you are audible.
Okay,
Santosh,
and I hope the screen is visible to all of
yes,
you.
yes. So Santosh,
Okay.
maybe first you do you have some slides on this approach, because I have not discussed this approach, no?
Ma'am, I do not have the slide, but I will go through the each step. I will explain every step, the
Okay,
data set, the approach,
okay,
and
okay.
everything, and then later on the score, how we have
Sure,
calculated
sure.
the score. Okay, so we have used the as the ma'am has already discussed, the the multi-objective optimization based clustering technique has been already utilized to solve the various text document summarization problem. So we have also used a similar approach to solve the one of the important summarization problem, that is scientific document summarization problem. So in each year there is a say a task competition has been organized in the 2016, 17, 18 and 19, and even 2020 as well. And the data set is publicly available. So what we have utilized this data set to solve the scientific document summarization problem using multi-objective optimization clustering based technique. So in our work, we have used the 2016, 2017, 2018 and 2019 data set. So the data set, all the data set format is identical. So basically what is our objective is that there is a scientific paper is publicly available, as you can see. So all the paper belongs to the ACL paper. They are the nothing but the ACL paper, as you can see here. So the title of the paper is given, and then abstract of the paper is also it is already annotated in the form of XML. So you have to extract the data, the text from the XML format to the normal text, and then the whole paper is given. And apart from that, what they have given, so the reference they have given the actual paper. Apart from that, how many authors have cited the paper, particular paper? Suppose the C002123 paper, the name of the paper was let me show the name of the paper. So the name of the paper was the word reordering and DP based search in statistical machine translation. So now the how many author have cited this paper, that is also given. Like in the annotation section, as you can see, the reference paper is also given. The citing article which cited this paper is also given. And apart from that, while citing the paper, what the citing author has written about the reference paper, that is also given. Like the citation text is this one. It is faster because the search problem for noisy. So something has written while citing the actual reference paper. So what we have done, we have utilized the citation text also to solve the scientific document summarization problem. So this is available in the annotation section. And apart from that, the gold summary is also given. Ultimately, when we develop any kind of technique, then we need some kind of the gold summary or reference summary. Comparing with we will going to evaluate our methodology. So there are three type of gold summaries available. The first one is abstract. So abstract is nothing but the abstract of the paper. So here the in the competition they have treated the abstract as the abstract can be considered as a kind of a summary of the paper. Then in the second section, the community summary is given. So community summary is nothing but the important line of the paper. So this is done by the human annotator. So human annotator have identified some important after reading the paper, they have identified that this line is the important. So it's nothing but the important lines of the actual reference paper. Then in the last, it is the actual human written summary is also given. So the human written summary is nothing but after reading the paper, the human annotator has written the summary. So it is the summary is abstractive in nature because it is written by the after reading the paper. So there are three different kind of summary here: abstract summary, community summary, and human summary. So when we are going to form the summary, then generate the summary, then we are going to compare our generated summary against these three summaries. So the data set is publicly available here. So now what we have done, we have used as I mentioned, differential evolution and multi-objective based clustering we have used. So this is nothing but we have already collected the data set from the actual website and converted into the normal text. So as you can see here, so actual data set was in the XML annotation. So we have extracted the text from the XML and converted it to the normal text. So that you have to do it. And then later on, what we have done, because we are doing the multi-objective optimization based clustering, and while doing the clustering you need some you have to use some kind of the distance measure while forming the cluster. So here like in the k-means, you are already aware that the Euclidean distance has been popularly mainly used. So in our case, what we are doing, we are using the non instead of the Euclidean distance, we are going to use the word mover distance. Word mover distance as a distance measure while doing the clustering. So how to decide the two sentences are going to be in a same cluster based on the word mover distance. So word mover distance is a well-known similarity. Can you can say that it's a kind of technique to decide to calculate the similarity between the text. Apart from the word mover distance, there are some other technique as well, like the Jaccard similarity, cosine similarity, and then in some extent the textual interment can also be utilized to find the similarity between the two sentences. In our case, we have used the word mover distance. So what we have done, so I am firstly I am showing the how the matrix look like. So in our case, what we have done, suppose there are 57 sentences in our reference paper. So what we have done, we have calculated the word mover distance between each sentence to each sentence. So, okay, sorry. Okay, so as you can see, the diagonal is 0. Okay, let me accept it. So diagonal is 0 because in any sentence, any sentence is going to be similar with itself. So lower is the word mover distance, maximum is the similarity. So that is the aim of the that is the what the word mover distance tells us. So in this way, we have already so what we have to do, like the word mover distance in the backend, it utilizes the embedding. So we have used like the Google News word to vec embedding to represent the sentences, and once we get the representation, means nothing but the representation of a sentence, we have calculated the word mover distance between the each two sentences. Then apart from that, as I have already shown, the title of the paper is also available, is scientific paper. So we have recorded the title of the paper. So title of the paper was the word reordering and DP based search in the statistical machine translation. So because ultimately we have to now we are going to feed all the information in our machine learning algorithm, that is differential evolution based multi-objective clustering. So we need some kind of representation of the title and all the sentences of the reference paper. So what we have done, we have generated the sentence vector of the each sentence and the title. So as you can see, for the each title, we have generated a title vector here. So title vector is nothing but the representation of the title. So it is a 1 cross 300 dimension. This is just a vector. So in this way we are representing the title. In the same way, we have represented all the sentences we have also represented in the form of vector, as you can see here. So let me open this. So okay. Sorry, this I have to open it in the. Okay, anyway, so here we have the vector for each sentences of the reference paper. So we like suppose there are 50 sentences in our actual paper. So we need some 50 sentence vector for that we are going to feed in our algorithm. And apart from that, as ma'am has already when discussing about the feature, the ma'am has discussed about some similarity with the title, position of the sentence are the important feature while doing the summarization. So we are going to utilize the similarity with the title as a feature while in our summarization technique. So what we have done, we have also calculated the similarity with the title of each sentence. So as you can see here, there was let it open. So there was 58 sentences, like 57 sentences in our reference paper. So we have calculated the title similarity with the title and the between the title and the sentences of the reference paper. So reference paper means nothing but the actual scientific article. So this is the and it is nothing but the word mover distance. So lower the word mover distance, maximum is the similarity. So why we are doing this? Because once we will, in the future we are going to cluster all the sentences using the multi-objective optimization based clustering. So once we will get the clusters, so we are going to pick the sentences based on this feature as well. So that is why we are recording the word mover similarity with the title in a separate CSV file, and that we will utilize later on. And apart from that, as I already mentioned, that there are three different kind of gold summary. So community summary, human summary, and abstract summary is also given. And the generated summary is going to we are going to store in the output section. So now I'm going to discuss the code of the paper, and also I will run the code and I will show you how we have accomplished the scientific document summarization. So as you can see here, so in our paper, like we have used the firstly, as you are aware, the Jensen NumPy is the basic Python packages. Apart from that, we have used the Roo score. So Roo is nothing but a well-known technique to evaluate the summarization algorithm. Apart from that, the Blue score is also used at some places, but the Roo is the mainly evaluation metric which has been frequently used to evaluate the summarization algorithm. So so what we have done initially, what we have done. So we are going to extract all the information what we have done, like the data, the actual summary, the title vector, and then word mover distance matrix, and then WMD similarity with the title, and then file path, and the path of the file is nothing but where we have stored all the different 10 paper. So in this 2016, the data set size was only 10. In the same way, the 2017 and the 2018, the scientific document corpus size is very small, like between 10 to 30. So that was the main reason to go for the follow the unsupervised approach, because in the 2019 the data set size of the scientific document corpus was around 1,000. So maybe we can think of to apply some deep learning based technique as well. But because when we started our work, so only the 2016 2017 dataset was available publicly. So we applied the unsupervised approach to solve this. So so get info is nothing but it is going to record the WMD matrix, WMD title that we have already calculated, the title vector. Actual summary array is nothing but the sentence vector, and the data is the text only. So that we are going to extract it from the get info function, and then what we are going to then that thing is we are going to pass like in the different section of the code, and then initially what we are going to give the minimum cluster to we are going to give the range of a cluster, like minimum cluster, what could be the minimum number of cluster and maximum. As you are already aware, there is a like the limit of the limit on the number of clusters. If we have the 10 suppose we have the 10 sentences, the number of cluster can't be the more than 10. So apart from that, because we are using the differential evolution algorithm is a kind of evolutionary algorithm. So each solution has some kind of fitness, and the size of the population is. So we have defined the population size as well, and the fitness count that we have decided this parameter after doing some literature survey. So you have to do, like if you are using the genetic algorithm as well as any kind of evolutionary algorithm, you need to set these kind of parameter. So now what we are going to define here, we are defining the problem in the form of ZT3 definition function is defining our problem. So what we are going to declare in this, let me show you. So we have a population, and the population has the property like solution length, data, and then text. Data is nothing but the representation, sentence vector representation of all the sentences, and text data is the textual data, and the word mover distance matrix that I have already shown. We have calculated the word mover distance matrix between each sentence to each sentence that we are going to feed here, because when we are going to cluster the sentences, and then underlying strategy is nothing but the only k-means k-medoid only. But why we are going to use the differential evolution? Because we do not want to fix the number of cluster initially, and that is why the clustering is treated as like a optimization problem, because we don't know how many number of cluster will be in our data set. So in the differential evolution, what we are doing, we are going to initialize some random population, and in the population we have some solution, and the solution has the following property, like the solution length, data, text data, and word mover distance. Apart from that, because when we have the population, in the population we will have some set of solution. So how we will get to know which solution is the best? So we are going to calculate the goodness of the solution based on the two objective function. So that the one is the PBM index and another one is the XIB index. So PBM index and XIB index, these are the two well-known cluster validity indices which check it works on based on the compactness and the separation. And apart from the PBM index and XIB, there are some other cluster validity indices as well, like the Silhouette index and many others. But we, in our work, we have used these to work, and we are going to optimize these two objective functions simultaneously when we are going to perform the clustering. So we are going to optimize these two functions. So based on these two parameters, we are going to decide which solution is the best one. And later on, because there are two parameters, so we need to do some kind of the non-dominated sorting as well, because some solution will be better in terms of F1, but some solution will be better in terms of F2. So to resolve the tie, we need to sort all the solution in the form using the non-dominated sorting. And after doing the non-dominated sorting, we will get some various front, like the front 1, front 2, and front 3. In the front one, we will have the best solution. And as the ma'am already discussed about the crowding distance operator, and suppose we want to pick the sentences from the front one, and there is so many solution has been crowded, so the sentences which is isolated from other solution will be the best one. So that is the aim of the crowding distance operator, to choose the best solution from the best front. So in this way, this is the whole the phenomena of our the methodology. So firstly, we have defined our problem using this function, and then the ZTT function. Let me show you what the ZTT function is doing. So so this is our ZTT class. So here we are, as we have already told, we are going to perform the non-dominated sorting. So in this function, we are calculating which solution is the better. So here, each individual solution is called as the individual. So we are going to calculate in terms of the F1 and F2, which solution is the best one as compared to another solution, and then on basis of that we are performing the non-dominated sorting. And in this function, we are going to generate a particular individual. So when we are going to generate a particular individual for the population, so we need such kind of information: maximum cluster data, word mover distance metric, number of feature, maximum length of the population that we have already initialized while run in the main Python file, and then fitness evaluation counter. So these are some parameters that we have to give while running the code. Then calculate objective has been called here in the non-dominated sorting while deciding which function is dominating other functions. So we are calculating the objective function, and basis of that we are going to decide which solution, or you can say the individual, is better as compared to the other. So that is the task of the ZDT. But because as you are already aware, we are ultimately using some evolutionary algorithm. And evolutionary algorithm means our algorithm is going to evolve in subsequent steps. So we are going to start from some random solution. So random population means some random solutions, and within solution we have some different set of clusters. Suppose in the solution one we have initialized 5 clusters. In the solution 2 we have initialized 3 clusters. In the solution 4 initialized 10 cluster. In this way, suppose we have the 10 solution, and the whole set of solution form a population. And in the later on, we are going to form after doing the crossover and mutation kind of operation, we are going to form new population, and again we are going to calculate the goodness of each solution based on the two objective function. which solution is the best one. Then better solution will further participate in producing the next population. So that is the whole aim of the differential evolution. The differential evolution is quite similar to the genetic algorithm, but the only difference is that in terms of it uses some unique kind of mutation operator. It has some difference as compared to the genetic algorithm. So that is the main difference between the genetic algorithm and the differential evolution. So in the evolution section, we are going to do the same thing. As you can see here, like initially we are going to define our in the something like the as I've already mentioned, we are going to use the NSGA2 because NSGA2 is a well-known NSGA2 is a well-known optimization technique for in this paper only NSGA2 paper the non-dominated sorting has been introduced. So we are using in our work. And then we are going to decide the population, the number of generation, the fitness evolution, then how many generation finished or the number of individuals, then mating pool size. So in this function, we are going to store all the population which are going to be generated. Then in the evolve section, we are going to create initial population. So create initial population is generating the initial population using this information like the maximum cluster data, then word mover distance matrix, number of feature, and then maximum length solution, fitness evolution counter. All these information are going to be used while generating a population, or you can say the population is contain mainly the set of solution or individual, you can say. So that is the what the evolve function is doing. And apart from that, meanwhile, we are going to use the SOM as well. Why we are using the SOM? Because we want to map the higher dimensional data into the lower dimensional space. So in our work, we have also utilized the SOM as well. Once we have the initial population, then we are going to use the SOM to map it in the lower dimensional space. And then later on, we are going to use that data to further to generate the further population. So that is the aim of this code, the evolution.py code. And this function is nothing but we have plotted when we are calculating the non-dominated sorting, we have plotted on using the matplotlib as a kind of function. So we have ultimately we will get the plot, and we are going to plot the goodness of the solution in terms of the PBMM and ISIBN index and the two objective functions that we are using. So this was the what the evolution is doing. Then we are going to store all the population in a list. That is what the register the new population is doing. Then the final final population evolution.evolve. So let me show you what the evolution.evolve is doing. So I will also run the code, and it will take it will take around like 1 hour time, but I will just run the code and will stop the code after a few minutes, and then I will show you the gold summary and the score, how we have calculated the score and everything. So I think the evolve I have already discussed. So once we have the after evolution.evolve, we will come to some set of solution, and when we are going to get to know when we have to stop. So after reaching the termination criteria, we will stop the further evolution for generating the population, and at the end we will terminate with some set of solution. So in the some set of solution, so we have many solutions. So ultimately we are going to use only some good solutions. So we will perform the non-dominated sorting, and we will form the front, and from the front one we are going to pick the best solution, and that best solution within the best solution, ultimately what we will have some setup cluster only, and within the setup cluster we are having only the sentences of the difference paper only. So our whole aim is to reach to the best cluster first, and then our objective is to reach to the finest sentence for the summary. So to reach up to to pick the finest sentence for the summary, we are going to use some different feature. We have decided the features based on some literature survey and based on some our experimentation, which feature will be the best to form the summary. So as we have already given some range between 1 to 16. So this is nothing but based on the label we are going to group the sentences in a particular cluster. So once we have the cluster, so now what we are doing, we have come to the stage where we are going to form the summary. So we are going to extract the sentences based on some feature. So there are four different features that we have used for the scientific document summarization. So firstly, we calculated the sentence length, like the sentence which are longer in the length can contain the crucial information from the reference paper. So we have pick the sentence which are longer in length. In the second feature, what we have done, the sentence position we have taken as an important feature. So the sentences which are coming early in the document, we have given higher priority while forming the summary. So in the same way, the third feature was the similarity with the title. As I've already discussed in the starting, that we have calculated the similarity with the title and stored it in the form of a CSV. Now we are going to utilize that information here. We, for all the sentences, we have the information. So the sentence now, the sentence which is closer to the title will be given higher priority and will be included first in the summary. In the same way, the next one is the anti-redundancy. Anti-redundancy is a kind of a technique. While generating the summary, our aim is all the sentences which will be the part of the summary should not be similar to each other, because then only we can achieve the maximum coverage when all the sentences will be different to each other. So anti-redundancy, what it does, firstly we are going to include a sentence in the summary, and later on we ensure the next sentence which is going to be the part of the summary should not be similar to the sentence which are already in the summary. So that is what the anti-redundancy is doing, and we achieve this based on the word mover distance again, because word mover distance is a kind of well known and it's a quite good technique to find the similarity between the sentence. So apart from that, here why we have calculated the distance from the center and then dog center, because suppose in a solution we have 5 number of cluster. So from which cluster we should start the clustering process, and which cluster should be we give higher priority. So what we have done, suppose we have the 10 sentences in our document. So firstly we calculated a document center, and document center means the sentence which has the least average word mover distance, that will be called as the document center. So let me explain. Suppose we have 10 sentences, so we are going to find the word mover distance between first sentence and remaining 9 other sentences. From then again second sentence, and then remaining 9 sentences. So at the end, we will calculate the least average word mover distance for all the 10 sentences. So the sentence which has the least average word mover distance will be declared as a document center. And again, in this algorithm we have used the cameloid clustering. So our cluster center will be nothing but the sentence of the document only. So once we have the document center and we have the 5 cluster, so we are going to find the similarity between the document center and the cluster center. So the cluster which is closest to the document center will be assigned rank 1, and the sentence which has the maximum distance from the document center will be assigned least rank. So in this way we are going to assign the rank. So I think I hope you got my point. So in the solution we have some set of cluster. So firstly we are forming the ranking order, assigning some rank to the cluster. Once we have done the ranking, so we are picking the highest rank cluster first, and within the highest rank cluster we have some set of sentences only. And to pick the sentences from the cluster, we are using these 4 different features, like the sentence length, sentence position, and then similarity with the title, and then anti-redundancy. And these are the 2 things are utilized to rank the clusters, assign just do the ranking to the of the clusters. So in this way, and at the end we are going to pick the sentences, and we are going to store because this approach is nothing but made for the extractive summarization. Extractive means we are going to pick some important sentences. So there are 2 way to summarize a document. One is the abstractive summarization, and another one is the extractive. So abstractive summarization is nothing but like someone has written the summary after reading the whole document in their own terms. So solve a document in an abstractive manner, we need some kind of generative model, like the encoder decoder based model we have to use. So in our case, because our approach is a unsupervised approach, so we are using extractive we are working in an extractive way. So in this way, a predicted summary, we are storing the predicted summary here, and we already have like the actual summary. So what we are doing, we are going to calculate the the score between the actual summary and the generated summary based on the rule score. So now let me show you the one score. So this is the one score. So in our case, there was a constraint that the generated summary should be between less than 250. So we have also recorded the summary length. So this is ru1r, ru1p, ru1f. So when you will use the ru package, so by default it will give you the ru1 recall, ru1 precision, and ru1 f1 score. So we have used the f1 score only and reported in the paper. So ru1 is nothing but the unigram match. So we once suppose you have the generated summary and you have the actual summary. So what the ru1 is denoting, it is denoting the unigram match between the actual summary and the generated summary. So we have we have three different gold summary. So we are going to calculate the rule score against three different gold summary. The first one was the abstract, second one was the community summary, and the third one was the human summary. So we have reported the score for all three different summary. Similarly, the ru2 is the bigram match between the actual summary and the gold summary. And then the ru-L is nothing but the longest common subsequence match between the actual summary and the generated summary. So these are the three variation of the ru. And apart from that, there is a further, there are two more variation that we have used to calculate calculate the score. So this is the ru3 match that this is nothing but the trigram match between the actual summary and the generated summary. And ru-su4, it uses the two things like the scriptgram and unigram both. And while it is considering the scriptgram, it is considering up to the length 4. That is why the 4 is written here. So ru-su4 in at some places it is considered better as compared to the other evaluation metric. But for the scientific document summarization, because the all three evaluation metric has been reported by the other author, so we have also calculated the same. So in this way we have calculated the summary. So let me show is there any like predicted summaries is with me, like, okay. So this is the one of the predicted summary. So as you can see here, like the in the XML file, at some places like that they have not removed the special character from the actual corpus. So we have also not altered the actual their altered corpus, but this is only with the sum of the data samples. They have not what kind of data set they have provided. So they have already not left all the special character, the mathematical symbol. So we have also used the actual corpus to solve so that we just to do the fair comparison between the actual using the actual data set. So in this way, as you can see here, we have gone through the this is the predicted summary for the another data set. So for the all the 10 data set, we have worked for the all the 10 data set and done the same thing like the perform the clustering and then form the summary and then computed the score for against three different summary like the community summary, human summary, and then human and human summary. So we have calculated three different scores. So uh, this work has been accepted in scientific in applied intelligence. So you can find our paper for more detail. You can find like this. It has been accepted in the scientific in applied intelligence. So for more detail, you can go through our paper and you can find the more detail here. And if you are interested to work in this direction, you can further contact us also. So so in this way, so approach is generic in nature. So we have utilized it for the scientific document summarization, but using this approach we can approach any other scientific document summarization problem, other summarization problem as well. But the only constant is then, because this technique is made for the extractive way only. So if you want to solve the problem in an abstractive manner, then you have to go for the encoder decoder based generative model, and then you need you need more data set. But in our case, as you can see here, when this data set released, like the 2016 test data set, so data set size was only 10. And in the latter year, I think this year also, the competition is going to be organized for the scientific document summarization. So if you any of one of you interested, you can use this corpus. So so that is all about the scientific document summarization in using the multi-objective differential evolution based clustering. So if you have any question, please feel free to ask me, and I will be happy to discuss with you.
So,
Please put your question in the Google like chat section. I will.
So participants, if you have any questions, you could ask Mr. Santosh Mishra, who is delivering the lecture very swiftly.
So also let me run the code. Okay, I have not shown you the let me run it again. Actually, I have already run, but it will take few minutes to like at least 1 hour it will take to run the. As you can see, I have already run, but meanwhile I have stopped it. So as you can see, we are going to generate the some population, and we are calculating the root score. So in this way, the whole code is going will run. So just because it will take so I can show you it will take at least the 2-3 minutes to it will start running. So meanwhile, if you have any query or question, so we can discuss. So what is the difference between
Question.
okay, so blue is mainly like in the blue we have the in the summary we usually have the longer sentences. Like the blue uses the some internal concept, gravity penalty concept. It also included in their mechanism. So that is not in the case of the root, because when we are going to calculate the root score, the sentences will be much longer as compared to the like blue is mainly used for the machine translation, image captioning, visual question answering. But I have seen only very limited place where the blue has been utilized for the summarization. So RU is more popular as compared. Everywhere you will see the RU score only, because the RU and the blue, because uses the gravity penalty for the shorter sentence. That is not in the case of the RU. So that is the main difference between the blue and the RU. And because blue penalizes the shorter sentences when calculating the score, and the root doesn't use this concept. So that is the case, because when the summary, when we are going to calculate the summary length is 250, going to be 250 or more than that. But when we are going to use working with the machine translation problem, the bold sentences, actual translated sentence, and the reference sentence is not going to be like the 100-word length. It will be only between the 5 to 20 or 30 word. So that is the for the shorter sentence. I think that is why the blue is only mainly popular for the image captioning and machine translation. So for more detail, I think we have to follow the actual paper, like the ACL paper. Both are the ACL paper, blue and the blue. So any other question?
Hello.
Yes, sir.
Okay. Santanu,
Yes, sir.
please instruct the audience to put the question on the chat box.
The question is there that what is the difference between blue and brown? but that question is already been answered by Mr. Santosh Mishra.
Okay.
Now he was asking for some hands-on training, so we are waiting for that.
Okay.
So, Mr. Mishra.
Yes, sir. Sir, I think you are muted. Please go ahead, sir. What you are saying, you were saying.
Actually, you want to go for some hands-on training. Is that over, or you want to go further?
Pardon, sir. Is what? Which training?
No, so Santosh, your hands-on is over.
Yes, ma'am. Actually, ma'am, that ma'am, ma'am, that I wanted to show the execution. So, ma'am, this was the execution that ma'am. Yes, ma'am. I have already discussed everything, and I wanted to show the execution, ma'am. So this in this way, ma'am, we are. So that is the ma'am. Now the ma'am code is running. So I have gone through the every module, ma'am, and how we have. I have discussed everything, like the multi-objective based clustering and the different component of the multi-objective differential evolution, multi-objective clustering, all the thing. So, ma'am, I was just waiting for the questions, ma'am, after discussing everything. So,
Mr. Santosh.
Yes, sir.
I think question answer session will the whole participant, because if you run the thing on the screen, it will be it is very difficult to understand each and every code. So, let's audience put your question on the chat box, and by that, Mr. Santosh can give the.
Yes, sir. Yes, sir. That will be the good, sir. Yes.
I
Yes,
think
sir.
that will be better.
Yes, sir.
So, if there is any question from participants, you could ask. Otherwise, we'll sum up the session. So, do you have any questions from participants? Okay. So Mr. Santosh, there is no more questions here.
Okay, sir.
So we would like to thank you for delivering such a wonderful lecture.
Okay, most welcome.
And also, thank you so much, madam, for delivering such an outstanding lecture on the journey of ML to DL from computer vision's point of view, which is very much informative, which are sure, we are sure that all the participants have found delivered lecture to be extremely beneficial in the implementation in the research world. Now, there is a small token of appreciation we would like to present to you.
Thank you very much, Dr. Abhijit.
Abhijit.
So,
Abhijit.
Yes, sir.
I want to say something.
Yes, sir. Please, sir.
Triponda madam.
Yes, sir.
Being a head of the department, myself, Dr. Subhankar Joardar, I'm really very much thankful to you for this nice session. I have gone through your whole session. I remember in the last year also, you had a nice session, and we have got a massive appreciation by the fraternity. In the last year, you remember, in the month of November. So,
yes, sir. I do remember, yeah.
really we from the Department of Computer Science and all the department like CSC AIML, CSC Data Science, and CSC Cyber Security, we're really thankful to you. Hope that you will associate with us in the long run in the future also with this kind of session that will help a lot to the research fraternity like us. Thank you, ma'am.
Yeah, thanks a lot for sir for the invitation and for remembering me. Yeah, next time I really would like to physically meet you all. Yes.
Thank you, ma'am. It's a nice, it's a pleasure for all of us.
Yeah.
Thank you, ma'am.
Thank you. Thanks a lot.
Okay,
Okay. Bye.
okay, Shantanu.
Okay.
Thank you
Um,
all. Again
Thank
tomorrow.
you all for attending today's session on the FDP. See you on tomorrow. Have a nice day. Thank you.